Hey, in this video we are going to build a little NodeJS server. It's the second part of this little video series. In the first video we created the front end. If you didn't watch that video yet, check that out. In this video we are going to build the back end.
And I already have an empty project up and running, and I have the front-end application up and running locally. So we have this registration page, and we want to build the API that allows us to register a user. So first of all, I'm initialize a new npm project. So I say npm init -y. The -y flag will skip all the configuration stuff. And you can see it's empty, and we use some dependencies. So this server application is not vanilla JS, if you want to say it like that, because we are using some dependencies that help us building the application. And it's pretty hard to build a whole server application without any dependencies. At least the database driver is needed. So we are using Express. So we say npm install --save Express, and we use the latest version 5. Now we have Express installed, and we can add actually our application script. So we have a new directory source, and inside the source we add the app.js file. ExpressJS is pretty straightforward. We can just create the app by calling Express, and therefore we need to import Express. And in order to run the application, we want to say, okay, listen to a specific port on our local host to accept HTTP requests. And we say, okay, how less the port will be 3000. So we say const server is running on port. That's nice. Let's put a little emoji in here, and let's put that port on the very top. And now let's add our very first route listener. For any get HTTP requests coming in our default URL, so on localhost :3000, what do we want to do? We just say response.send hello world. All right. Now let's check this out. I just need to run this. So we go to the package.json and add a start script that is just executing node of source app.js. And then we can just say npm start. Oh, okay, there's a comma. One more time. All right, now I get the issue that I'm using the import syntax and not require. And to change this, you need to add type module to your package.json file. That should solve the problem. So let's try it again. Here we go. Now, if I open up a browser and instead of our front-end application, open port 3000, you can see hello world. Now, if I change hello world in here to something else and reload the page, you can see nothing happens because the server needs to restart to have those changes. And to not restart the server all over again, there's a package that helps us, and this is called Node1. And this is a development dependency. So I say save -dev. Okay, and now instead of calling node on start, we say node1. And let's call npm start. It's running on port 3000. If I reload, it says hello you. And if I now go to my app.js file and again write hello world, reload the page, it's automatically showing this. The next thing we want to do is we want to have a folder where we put all our API scripts in that define how our API looks like. So let's have a directory API and put our very first API in it, which is the user's API that allows us to log in. So from our application, if I go to the register page and enter here and I click register, it makes an HTTP request to our server on /users/register with the email and the password in the body. So we want to get this. So let's add a new directory API. and we add a new file, users api.js. And this one is exporting a default function. In ExpressJS, you actually have the possibility to create routers, separate routers, and then you can register them here. But I like a different approach. Instead of register every API manually, we actually can replace this with a little logic to read every script inside the API folder and automatically apply all the routes you define there. So let's do that. Let's have a function that is a function that is async that is called import API, and it gets the file name. This is already looking okayish. I would like to have the path to API here, and it's under source API. That's correct. But to be sure that this one is working correctly, I like to use the absolute path. So I say resolve that one, okay? And then we have the path to the API, and what we do here is we say path.join path to API with the file name. So what this does, it's importing the module from that folder here, and this is asynchronously. That's why we need to await it. And then in that module, we call the default export, which is a function. What we did here, it's a function. It gets the application here. And this is a function that we export, and we call this one here and pass this express application. And the nice thing about this is in our API here, we can now apply all the routes we want to get. So for example, let's put in this post for /user/register. And then we have this typical route handler of ExpressJS that gets the request, the incoming request, and the response object. And then we do our logic here later on. But there's something missing. Of course, we need to read the directory first. So we use the fs package from Node and say we read the directory of our API. And for every file that we find in that folder, we call this import API. Easy. So let's try if that's working. Let's put just on the slash get. We do the same logic. We just say response.send hello world, and let's again put the path back, and there we go, nicely. And we can add more and more and more here, and it's always automatically imported by our simple and nice script. Currently, the API does not support a JSON import, so therefore we need to tell Express to allow JSON, and that we just say app.use express.json. This allows us that when we make post requests and the body of the post request contains JSON, that it actually passes this. So for our first API route we need, that's the register route under /users, we expect that the request body contains an email, not check email, an email and a password. And I would always like to check if that actually happens. So let's add a new directory for utils. So I have a directory util, and I add a script that I call expect type. And I export a function. So I can call this with a value, and I would like to have the type first. So I say like I expect type. So I say, for example, string, and then I pass the value. And if the value is not a string, I throw a type error. So there's an inbuilt error, type error in JavaScript you can call. And I also want to have the possibility to pass a custom message if needed. So it's printing the message or a default message, expected type, but got type of value. That's nice. It's a type error if that's not the case. And we can create some shortcuts for strings and numbers. So we can say expect string like that. And we can do the same thing for numbers and also for Boolean. All right. And in our API, what we can do now is we can say expect a string. And we do the same thing here. Message user registered. It's not registered. We need to implement the logic here. We come to this in a second, but I want to show you how that works. First of all, this is throwing an error. So what happens now if I make this post request? So if we just open our application, go to the registration page, I open up the network tab so that we can see what the API actually returns. And I just say register. It says course error. And there's another thing we need to make. Course means cross-origin request security. Currently, our application, or the client application, is running on the domain with the port 5173, and our server is running on port 3000. These are two different domains and two different origins. And the cross-origin request security of our browser does not allow to make those requests from one to another, except if we tell our server that we allow this. And there's a package you can install, so it's just called course. So we say npm install -save course. Here we just say app.use. And of course, we need to import that one. Import course from course. So now let's start the server again with npm start and check that out again. Foop. Now we get 200 and everything is fine. So that works. But let's imagine we have a mistake here. Let's say actually the client is sending an email, that's correct, but let's say we actually expected a username instead of an email. So I send the same. Bam, but this time I get an error. And you can see it's sending me an HTML. It's an ugly error. It says, oh, I'm on the wrong page, by the way, but this register sends me a 500 internal server error, and the response is very cryptic. Now, this is because we do not have an error handler. ExpressJS allows us to build a nice and easy to use error handler, and we want to do that. And all we need to do is in our app.js at the very bottom, after we imported all the APIs, we add one more handler that is on app.use. And this one gets 4 parameters. First is the error, second is the request, the response, and the next function. Since Express version 5, whenever an error is thrown in here, it's automatically calling the error handler, even if it's an async function, even if it's asynchronously. So first of all, we make a check that the headers are not sent yet. That's very important. So if you in your route handler in your API already called response.send, and afterwards an error is thrown, we want to ignore that case because then we don't need to do anything. The next thing you want to do is like we grab the error and we grab the message from the error and split it with a colon. I want to show you that. So let's expect we are throwing an error message that looks like that. We say if the username isn't a string or is not existing, we say 400, which means bad request. The HTTP status 400 means bad request, and say username is required. And we do the same thing for the password. So if we now go to our app.js, we split that error message. We know that the first value in front of the colon is the status code and the second one is the message. But it's still a string. The status code needs to be a number. So we are going to parse the status code into the status number. And then we just send that one. We say, okay, if there's a status, we just check if the status does not fit. So for example, if the error message is not thrown by us, maybe it's an internal error somewhere, we just say 500, and then we send the error as a JSON. So it's importing those asynchronously, and it's not waiting until all the API scripts are imported, and the error handler needs to be the last one called. So let's change this. So now the wait is on the top level, so it should do that in order and should await until all the scripts are loaded. Let's see if that's working. And now it's working nicely. So now we get the error message, we get the status code 400 because it's a bad request, because in our application, our API, we expect that we get a username property, but currently the frontend is sending an email and it's sending, okay, this is a bad request because the username is required. So now let's change this back because we are actually expecting an email. Let's try this one more time. And now we get user registered 200. Okay, so beautiful. Next of all, we want to actually store the user credentials in our database. So we need to have a database. And of course, we can apply any kind of database, Postgres, MySQL, whatever we want to have. But this time we make it very easy and just use an SQLite database. The SQLite databases are just stored in a file, and we just do this directly in our project. So we add a new directory that we call data, where all our data of the application is stored. That, for example, image uploads, our database, and so on and so on. And in our app.js, where we set up our application, we now set up the database first. And of course, we first of all need to have the database driver. And there's a database driver that is called Better SQLite 3. So we go to our terminal and say npm install --save Better SQLite 3. Then we need to import this. So I say import database from Better SQLite 3. And we want to have the path to database. And we again use this path.resolve to get the absolute path to that file. And it's always starting at the project root. So it's like data, and then we have a file that's called data.db where our stuff is stored. To initialize our database, we just use the constructor. So we go in here and say const database is new database. And then there is something you need to do. You need to call this pragma and set the journal mode to WAL. This is recommended in the description of the SQLite database stuff. So we just do it. And then we want to do one more thing. We want to pass that database instance to all our API scripts. So here where we call the script, so that's what's coming in here, we want to actually have the database. So let's add the database here and pass the database here. All right. So we have the instance to our application and the instance to our database everywhere available. Beautiful. To be able to store the user data in the database, we actually need to have the user table in our database. And therefore, we need so-called migration scripts. Migration scripts are scripts that run on every restart of the application and just check if the structure of the database is still up to date, and if not, runs the migrations. So we add a new directory that we just call migration. And in here, we add a very first SQL script. So it's the very first. I always put a number at the very beginning to be sure that the scripts are executed in the correct order, because again, we will implement some logic to read automatically all the scripts in the folder and just execute them. So the very first is called add user table.sql, and we just keep it very simple. I just copy that in, some SQL, so create table if not exists, we actually can skip that, but doesn't matter. User, it has an ID that auto increments, so it's a number, which is also the primary key, and it has this auto increment flag, which probably every SQL database has this feature, auto increment. It means that we don't need to set the ID manually. You can just add new values to that database via email and password, for example, and it's automatically generating the ID for us. And yeah, we have the email, which is a text. It's not null, so it's required. Password the same. And we have every user probably has an image, so an image path to an image that we store in the data folder, which is optional for now. So that's that. And now we need to execute that on start. So we are reading all the scripts in the migration folder. So we first of all need the path to the migration folder. So path to migrations, it's under source migration. And then we do exactly the same thing as below, but this time it's not asynchronously. So it's fine to do it in a different way. We just call this, yeah, that's also what we need. But first of all, we need to say read file. No, we don't read it. We read the directory synchronous to the path to our migrations. And then we call a function that is called run migration. So let's write that function run migration, and it already suggested this code for me. What does that do? Start from the very beginning. First of all, it's executing an SQL statement here where it says select star from the migration table. We don't have a migration table where the file name is equals to the file name. As you can see, we go through the folder where all our migrations are lying and run for every file in that here, we run this migration. So we get the file name. The file name is 0001 add user table.sql. And we look up in this table if there is a record with that file name, but we don't have that one. So we need to create the migration table first. So let's do this. So we just take our database instance and say execute, create table if not exists migration with only one column that is called file name, which is automatically the primary key and of type text. And we do this before we actually run our migrations. Then when we run the migrations, we check if in that table, in that migration table, is the file, is a record with that file name. If that's the case, so if it's migrated, then we skip. We just return, make an early exit here and put some console log to say, okay, we already have that migration. The user table already exists, for example. If that's not the case, so there is no migration, and that's what it is right now. We say run a database transaction. That is a little bit fancy. Transactions are a nice way to run multiple statements secure. As you can see here, we run first one database query to actually run our migration. And if that was successful, we run another one. And the transaction ensures that if that first transaction fails, or if one of those transactions in here fails, the other one is reverted. So we ensure that our database is always consistent. And what are we doing here is we read the file to path to migrations to file name. So we read that file here with our SQL. We get the SQL and pass it to the exec function from our database. That means it's just executing our SQL script. If that was successful, we say, okay, now insert into our migration table the file name. So the file name that is 0001 add user table. That's it, migration ran. All right, that's our database setup. So that's the whole database stuff. Let's put in some region comment here so that we can toggle this. So that's all the database stuff. By the way, that's a nice thing you can probably do in every IDE, I guess. If you have this region command, you can toggle regions. And now let's give it a try. Let's check if it's actually creating the table. Bam, and it says checkmark migration. So it added the user table. Now in my IntelliJ here, I can have a look on the database. Let's have a look if that works. So we add a new data source of type SQLite. Okay, I selected the file, and now here I can see I have two tables. I have the migration table that if I call this says there's one entry for add user table.sql, and I have my user table which says ID, email, password, image, path. The table currently is empty. Of course, we didn't add any user yet. At the next step, we want to add the service that is actually interacting with our database. So we add a new directory that we just call service. And you can think about our application in two layers. You have one layer, which is the API that's containing the logic that is called first. So if I'm requesting the API with a post request on /user/register, it's executing this this part of code, and then it jumps one layer up to the user service. And the user service does all the business logic, so whatever we want to do, and it's communicating with the third layer, which is the database. And depending on your application, you might have like several layers, so even more. If you think about like any other application, like Spring Boot application in Java, Spring Boot, for example, you probably have more layers. Then you have repositories, for example, to interact with the database, and you have filters that are actually performed before your route controllers. So we add a service, and the very first service we add is a user service. And we have this as a class. That's why I'm putting a capital U here. So I export a default class. The user service can be instantiated. We do this because we want to have the instance to the database right here. So we say we get the database when we instantiate our user service and hold the instance to the database. And this is what we're doing right here in our API. So we say const user service is new user service, and we pass the database. And then we are going to call like save the user, right? So we have a function in the user service that we call like save user, and we pass the email and the password. We don't have that method, so we create it. So we grab the instance to the database, then we run prepare to provide the SQL statement. We want to insert into the table called user that we created the last time, and have email password with question mark, and then we just pass them. And we need to hash the password. As you can see here, we have this.hash password. We don't have that method yet. So let's create a function that actually hashes the password. If you're not familiar what hashing is, hashing at the end makes the plain text, so the password, unreadable and stores it into the database, and you cannot revert it. That's the main thing. You might wonder like, okay, if I cannot revert it, I cannot figure out the password, but it's actually what it is. And when the user logs in, you just hash the password that comes from login again, and you compare the two hash passwords. They should still be the same. So that's something that happens when you hash something on the same input. You always get the same output, but it's extremely hard, nearly impossible to revert it, to you get the original thingy, the original plain text from the hashed value. There is a create hash function that comes with the crypto package from Node.js. We need to update that with the password, and then we want to say like, how do we want to have it? I say we want to have this as hexadecimal, hexadecimal, so hex. You can also store them as base 64. That doesn't really matter. So on save user, we store the email and password inside the database. There's one more thing we need to do, and it's actually we need to check if the user already exists. And actually, that's something we need to do on the database. We need to say that this is unique. So we can actually just drop the unique statement here to say if someone tries to add another email that already existed here, we just drop an error. So this is done by the database. And by the way, that means we also need to delete the database for now. We could actually add another migration script to say, okay, add this unique constraint. But as the database is still empty, we just can't delete it, and it's just running the whole script again. But still, if the database throws the error, it's pretty ugly, and we want to have actually a better error. So let's have another method that we call email exists. And the email exists is just selecting from the user where the email is equals the one that gets passed and returns a Boolean. And in our API, we just call that 409, which is the HTTP status for conflict, and we say email already exists. If that's not the case, so if there's no one with that email already, we say, okay, save that user. And then we say, okay, user registered, right? And that's it. That's it. Let's give that a try. Okay. And then we just check that page. We're on the login page currently. So let's go to the registration page and register that fake email here. That seemed to work. So let's have a look in the database if that is actually there. There it is. That's our user table in our SQLite database. And you can see there's this fake email account with the ID 1. It has no image path and it has the hash password, which is not readable. Beautiful. So what's next? Next is the login. And this is interesting because we want to use JWTs, so JSON Web Tokens. And there's a library that is called JSON Web Token that we can install right away. So actually, we can build JSON Web Tokens on our own because it's not that complicated. But yeah, this JSON Web Token is also pretty safe. Okay. Then we add another route here, which we just call app.post users login. We expect the email and the password again. That's fine. And then we have an authenticate method now. We get the email and the password. And let's see. First of all, we are actually creating our database to see if to get the user. If there is no user with that email, we throw a 401 error to say, okay, you're not authorized. We don't know you. Then at next, we check the incoming password and hash it and compare it with the password that the user has in its database. If that's not equal, same thing, not authorized. If it's equal, so that's the last statement, so we know, okay, everything is fine. We actually return the JWT, so the JSON Web Token as a shortcut. We need to import a JSON Web Token from this JSON Web Token package we just installed, so that works. And the JSON Web Token is signed with the user ID we pass in there. Now, a JSON Web Token is always built up out of 3 parts. It's actually just JSON base 64 encoded, and then it has a signature at the end. So it's it's 3 parts. The first part is just the header of the JSON Web Token that says like how is it created with which algorithm. The middle part contains the information we provide here, that is the user ID, and the last part is the signature. So everyone having the token and the secret can validate that JSON Web Token to say, okay, you have this token, so that's kind of a key. So you are allowed to do something. In our case, it means, okay, you are authenticated, you are allowed to use our application. And as you can see here, this secret comes from process.env JWT secret. And the reason for that is we don't want to hard code the reason in our code. Instead, we want to provide this. There are 2 ways we could, when we start our application, we just currently started with npm start. We could pass some secret here to sign our tokens, or we could provide an .env file that we do not store in our Git. Don't put that on GitLab, GitHub, Bitbucket, wherever you are. Instead, this file should be only where the code is executed, so on my local machine. And you need to put this manually on your server when you run it there, but it should never appear on your version control system. So we have this JWT secret here, which should be actually super long and super secret and so on. I just put in some random stuff here. And we need to have another package, unfortunately, to read this this .env stuff. So we say npm install .env. And in our app.js, we need to tell the application that we actually want to use the variables from this .env file. So, and it needs to be at the very top. And that's it. And that should do it. If we import .env.config, it looks for a .env file like this one, which is like in a YAML format. So you have like key value pairs. You can, in your whole application, get those values by just calling process.env and then providing the key. Okay, so this should authenticate our users and return a JWT. Let's see if we can actually log in. So the last time we already registered the user and I'm logged in. That's amazing. So at Next, we want to add a new API that is only allowed for authenticated users. And therefore, we need this JWT. So let's create a new API file that we call messages API. I'm not quite sure if that should be singular or plural. I don't care. Default function gets the app, gets the database. So it's exactly the same as on the users API. And then on the app, we say post for incoming post requests on messages. We want to have the messages. All right. We need actually to have a new database table for our messages. So let's add a new script. So we say create a table of not existent message. It has again an ID auto increment. It has any content that the user provides. It has a user ID. Those are all not unique. So one user can have like a ton of messages. We don't care. And that's all fine. And we have the image path because a message might have an image. Now we need to add a service again. So let's have a message service. We first of all have one function that's called save message, exactly this one. So content should be the text. And we just say this.database, so the instance of the database, prepare the SQL statement with insert into message the columns content and the column user ID, two values, content and user.id. Where I'm going to do this like that, I expect to get the user ID here directly. All right, let's go to the message thing and say we want to have the message service here. So const message service is new message service. And we also need the user service. And I'll show you why. Okay, first of all, we make our type check again because we expect that the user is posting some content from, that's what we get from the client. And what we also want to have is we want to create a middleware. In Express, you can actually chain those. So you can put as much functions in here as you want. And every function is, or every callback you pass here gets 3 arguments, the request, the response, and actually a third parameter, which is called next. And you can always call next, and it's just calling the next function you put into this chain. So I can put just another one in here. And that's the middleware pattern. So you can have a lot of middlewares here. That would be exactly the same. So I can do something after that. And this makes sense because you actually can run something as a filter beforehand. And we want to do this right now. We want to authenticate our user. So let's have a middleware folder here. So I add a new directory, middleware. And let's have one here that we just call authenticate.js. And what this does, it's a default function. As mentioned, it gets parameters, response, send, and next. That's funny. No, that's not what we want to do. Our client application is always sending the token, the JWT, as a bearer token in a HTTP header called authorization. And we can actually read that. So we can get the token, the JWT from it. So we say token is from request.headers.authorization. but it always starts with bearer. That's how it is. So the value always has at the beginning bearer and then space and then the actual token. So we want to get rid of this bearer word. So we say, give me just that second thing. Okay, so that's the token. I can show you this in a minute how it looks like in the header. And so now we have the token. If there is no token, we already can send the status unauthorized. Actually, I'm interested if what happens if I throw an error here, if the standard error handler is handling this. And I think it should work. So we can just throw an error. So in case we have the token, we want to verify it. So we say JWT verify. And we import JWT from the package JSON Web Token. It's exactly the same package that we use to create the JWT in our user service here, where we say, okay, we checked if the password is correct, and then we created those JWT with JWT.sign. This creates the JWT, the token, and now we can, in our middleware, we can check if the token, if we get one from a request, we can check if it's valid. So we grab the token from the header, pass the same secret again, and then we know, okay, if there's an error, it's doing this, and we don't need to use the callback here. We and just pass the ID, and we just get the ID. So this verify method returns the content, the body of the token, and that's we pass as a body. We pass the ID. That's the body, the user ID. So we get the user ID here, which is nice. And that's also what we want to return. We get the ID. We expect that we expect a number. So we expect a number. I think it's still unauthorized. So throw an unauthorized error if it's not a number. And then we say request.userid is that ID. All right. And last but not least, we need to call the next method. So let's have a look if that works. So in our users API, we have login yet, it's fine. But now we want to send a message, and now we just say authenticate, which is our middleware. We just splice in here. We say, okay, you need to be authenticated in order to post a message. Then we expect that there is some content you send. We don't fetch like current user. Instead, we say request.userid to save message. So let's give that a try. That looks actually pretty nice. So, I have the application open. I just clear the network tab, and this is my first. So here's my first test message. I click post now. Poop. That's nice. It sends 404 because it already tries to get the messages, but we didn't add this controller yet. So, but the first one was successful, and it's nice. And here you can see this is the request sending from our client application to our server. And it sends a post request to /messages. And it adds as a request header an authorization field with bearer, space, and then the actual JWT token. That's what we have here in our authenticate middleware. Here is we check the authorization header. You need to check here it's all in lowercase letters. Only grab the value after the space. That's the token, and then verify the token. So now let's fake that the token is invalid. All right. So we are in the local storage, and we just change the JWT. So I go in here and just add a number at the end of the signature, which makes the signature invalid. So I try to again post a message now with this invalid token. Let's see if it works. It gives me directly a 500, which is not that nice actually, because the thing is it fails right here on this verify, and this is throwing an error, and probably it's nicer to catch this 500 error and throw an unauthorized error, right? And then we probably need to do this in here, and we actually can get rid of that, because if there is no token, it's of course invalid. So okay, So whenever an error occurs in here, we just throw an error. So let's give that a try one more time. It fails again, but this time it says unauthorized because the signature is invalid. Now if I change this again, so I remove the number at the end of the signature and send the request again, it should work. There we go, works 200. Now let's have a look into our database. And here you can see it has the messages with the user ID and ID. So that works pretty well. So we need to create one more API to actually be able to load the messages. So pretty straightforward. We have a incoming GET request on /messages only for authenticated users. We don't need the user in here. We don't need to fetch like via user ID, but we still want to be sure that only users that are logged in are able to load the messages. And then we say message service.get messages. So that's the method we need to add here. So get messages. On the instance of our database, prepare the SQL statement to select everything from a message, anything from the entity, so star from message. And we order everything by ID descendant. So the latest posts are returned first. And then we get all as an array. So, and as mentioned, we don't need the user service here actually. That is nice. So let's check if that works. And it works. So here's our application. We have the post we got. So that is nice. Foop. All right. And last but not least, we need image uploads. So we want to be able to post an image here. How can we do that? There's a nice package again, a nice NPM package that we can use for that. And we put this into another middleware. So let's open up the terminal and install Malta, is it called? So we call npm install -- save Malta. Malta allows us to handle incoming form data with files very easily. And we create a new middleware that we just call upload. Straightforward, short name, easy to remember. So we say default function, and it's not getting a file. It is getting the destination. Where do we want to store the data? We want to have like the base path. The base path for our data is data. That's why we just have a base data path that's correctly, and we use the path module of Node and call the resolve a function with data. So it's grabbing that folder here, but it creates an absolute path to it. That is better. Then we also need to have the max file size. For now, it's 10 megabytes. That's all fine. And we need to define, like, for the incoming request, what's the field name in the form data where the file comes in. So probably in the client, you call it file, as I did, because it's obvious, but probably you call it like message image or whatever. I just keep it as file, so easy as this. Then we need to have a function that is actually generating the file name with like, how do we want to store this on the server? And we need to import crypto from Node. So we have this random UUID function. This is generating a UUID version 4 for us. And every file name is just a random UUID with the original extension name. So if it's a JPEG or PNG or whatever, of the original file. And then we need to create a so-called storage object from with Malta. So we say, okay, Malta, which is the thing we just installed, let's create this storage instance. The destination is what we have. So it's the base path to just data plus, so there will be a subfolder for every destination that we pass here as a middleware. You will check this in a minute. And join this with path. So it's data / for example, images, message images, or something like that. And for every file name, call this generate file name function. And last but not least, we need to return this Malta middleware. We need to pass the storage here, and we have the limits where we have like this file size, and we have this request field name. So we expect that the file is coming in the form data field at the name file. All right, so let's use this in our messages API. Let's add a new route. So we have a new post route that allows the user to post images. So we say messages slash image slash authenticate slash comma upload. With the destination, we say message images. That sounds good. And that means that any post request coming to messages image will check first if the user is authenticated. Then we handle uploading file. So if there is any file coming at the property file in, and checks also like the file size limited, and put the image into this data folder under /message images. And then we get, this is what this multer is doing, it's setting the path to the file under request.file.path, I believe. This is what we expect. So let's put an expect string for request.file.path. So to ensure, okay, there's really an image that we got. We always want to add this file to the latest message of the current user. And so the flow in the front end is like if you select an image here, write a message, click post, it's first posting the message, and afterwards it's uploading the image, and it's always just grabbing the latest message. So let's have in the message service get user's latest message. So let's add this here, user ID, and it says select star from message where user ID is blah blah, desk limit 1, get user ID. Perfect. So we just want to have one record from the database. It's inverted, so the latest first, and we get the message where the user ID is equal to the ones we pass here. And so that should be the latest message. If there is no latest message, we are going to throw an error and say this is a bad request. There's no message, so you cannot upload any image. But if we did find the message, we say update message image path. So we need to have this method next. So we get the message ID and the image path. You know that our message table has this image path field, which is optional, and it's empty by default. So if you add a message, it's first of all, it's null. And then if you upload an image for that message, we call that method update message image path on the message ID with that image path. And update message set image path equals blah, where ID is equals blah. And so we have the image path and the message ID. That should be it. Super straightforward. And then we just send that success message to be, okay, it was successful, yeah. So let's see if that works. Fetch images failed because I don't have the server running. All right, here we are. Now let's try to upload an image. All right, 200 successful. So the post image worked. The read image didn't work. We need to check this in a second. So you can see it gives me a 404 because this root does not exist. And that's what we need to build next. But let's first have a look in our data directory. We can see there's our database, beautiful. And there is the message images directory. And there is an image. And there it is, beautiful. So how can we get the images? Actually, with Express, you can have a public folder, which is like a static public folder, and any file you have in there is available to the outside. But that's not what we want to do here. Instead, we only want to allow to have the image readable by authenticated users. And you can see it's already suggesting me the correct implementation. So on the GET request on /messages/ID, which is the message ID, we want to get the image of the message. So we get the message ID from the request parameters as a number. we ensure that the user is authenticated. And then we need a method that is called getMessageImagePath. Probably you know that is wrong. Let's have it like getMessage by ID, makes more sense. Yeah, let's add this at the very bottom. Let's grab star, so we get everything from message where the ID is equals to the message ID, and get that one. And we limit this at 1, limit 1. So there should be only one message, get message by ID. It should always return just one, and it should also notice because ID is a primary key, but still I like to have this limit 1 to ensure that it's easy to read. So in our API, get message by ID, this is the message. If there's no message, we say 404. And also like or, there is no message.imagePath. So if there's no message or there's no image path inside the message, this is how this is called. So yeah, that's my image path, can be null. Then we throw an error and say, okay, message or image not found. And last but not least, if we have it, we got the image path here, we can actually return that. And we want to check if the file actually exists. So we want to say fs dot exist sync message.image path. If that's not the case, we make like an throw error file not found. And in the other case, like, okay, this one exists, we say response.send file message.image path. And because we are storing the absolute path in our database, we don't need to call path.resolve again. Storing the absolute path to the image in the database might not be the best practice if you are changing the server and structure or whatever. It might be better to restore actually the relative path, so just data / message images. If you need to do that, just remove this path.resolve here, and should still work. But then if you remove it here, path.resolve, you probably need to add it right here when you want to send the file. Okay, let's give it a try. So should still be running, reload. And there it is. It's loading the image. We can upload images. Beautiful. So our server implementation is complete. So let's just make a full round trip. So let's have fake an email as a login. Or first of all, I'm not logged in. So if I go to my homepage, it redirects to the login. Then I can log in. I'm in. It's automatically loading the images, and I can post an image. That is me. That was fun. I hope you can take anything out of this, and see you next time.